I'm Chunkit, and my teammates and I, Yusheng, Kai, Wanting, Qiao and Kangli, together we present to you our data analytics with Pokemon Go. So as a brief introduction, Pokemon Go players are always on the hunt for rare Pokemon. It is not difficult to find Pokemon Go players to be hunting all around Singapore, moving around different places and sourcing for new areas to find new Pokemon. So as such, there is an availability of a large dataset of geographical information to scan for Pokemon. This dataset provides us with coordinates, terrain, time of the day, day of the month, as well as the month of the year for the players to find these Pokemons. However, the issue of having to crawl the entire dataset and to sieve out each Pokemon spawn data sequentially has been a bugging issue for most of the players. So, how does data analytics come into play? With data analytics, we are able to search through the large dataset in a short period of time. Moreover, we are able to find out the spawn rate and the area for the specific Pokemon. And using architectural analysis, we could actually make the search process for the Pokemon to be faster. So we can actually make the search process to be multi-threaded with the creation of more strings and running these multiple threads concurrently. Hence, with concurrency and multi-threaded threads, we are able to make the search process a much more efficient and faster process.
The dataset consists of 293,000 Pokemon sightings based on historical appearances. 4 features of the dataset was used. Firstly, the Pokemon ID, which labels the individual Pokemon from 1 to 151. Secondly, the appeared time of day, which indicates the time of the day when the Pokemon is seen, for example, night, evening, or afternoon. We concatenate the appeared day, appeared month, and appeared year to identify the date of the Pokemon sighting. Lastly, for terrain type, it indicates the terrain where the Pokemon appeared, expressed in integers. The integers are mapped to a location. For example, in the next slide, we can see that 0 corresponds to the terrain water, and 1 corresponds to the terrain evergreen needle-leaf forest. For the project, we will be looking into concurrent versus non-concurrent methods for the following. Firstly, does the Pokemon appear more commonly during the day or night? Secondly, which terrain does a particular Pokemon spawn the most? And lastly, what is the rarity of the Pokemon that appears on each day? We ran the tree analysis to determine the differences in efficiency between the concurrent and sequential methods.
For our first functionality, this function will return when a specified Pokemon tends to appear more commonly either in the morning, afternoon, evening, or night. In concurrent Pokemon.java, under getNightDay function, data is captured via stream, after which we will filter the data by Pokemon ID specified by the user before grouping them by appeared time column and the number of times they appeared. Lastly, we use max to compare each result to find out at which time of the day it appeared the most. In sequential Pokemon.java, under getNightDay function, readData function will return you a list of string arrays that contains the data of a Pokemon specified by the user. A for loop is then used to iterate through this data and count the number of times it appeared at a particular time. We then use another loop to compare the result to get our max entry.
Move on to our second functionality. This function will return the terrain that the specified Pokemon was spawned the most on according to past data based on the Pokemon ID input keyed by the user. First, we will set up the terrain by giving description to each terrain ID through hashmap in Pokemon.java. In concurrent Pokemon.java, under getTerrain function, string will be used to find all the terrain together with the total number of its occurrence based on the given Pokemon ID. After that, string functions such as max map.entry.comparing by value will be used to find the highest total number of occurrence of the terrain. Then, stream filter will be used to find the possible terrains that have the same highest total number of occurrence. Move on to sequential Pokemon.java. A for loop will be used to find all the terrain and its total number of occurrence based on a given Pokemon ID. After that, iterator will be used to find the highest total number of occurrences, and after we find the highest value, we will use another for loop to find the possible terrains that have the same highest total number of occurrences.
In the third question, we would like to find out the actual rarity of the selected Pokemon based on the average number of appearances for the whole of last year. In the non-concurrent method, we first call the getRarity method. Inside getRarity, we set up the rarity list into 5 different categories, namely super rare, very rare, rare, uncommon, and common using setup rarity. Then, we read the entire dataset and filtered out the selected Pokemon ID that was chosen by the user and stored them into a list. Using a for loop, we look through the list to count the number of appearances each day and place them into a map, with the key being the date and the value being the count. Using another for loop, we find the total number of appearances for the year and average the result. Through the average, we then use an iterator to find the rarity based on our rarity list. Next, we repeated the same method, however, using streams. Similarly, we call the getRarity method. Inside getRarity, we also set up the rarity list into 5 different categories as mentioned earlier. Then, using streams, we read the entire dataset and used .map to split the Pokemon data and use .filter to sift out the selected Pokemon ID. Next, using collectors, we count and group the number of appearances each day and stored them into a map. Based on the map results, we created another stream and used .average to find the average number of appearances for the year. Lastly, in our third stream, we filtered the values and used .max comparing by value method to determine the rarity of the Pokemon appearances based on our rarity list.
So these are the findings we obtained from running both the sequential and concurrent analysis. From the results shown, we can tell that less time is taken to complete the concurrent analysis as compared to that for the sequential analysis. We will now look into the reasons as to why we obtain such differing results. The first reason is due to the fact that we used 3 threads to run the 3 different analyses concurrently as compared to using only 1 thread in the sequential analysis. This means that every analysis done in the sequential is blocking, where one has to wait for the other to complete before it can begin. Time will thus be saved when we use multi-threading to run multiple analyses considering our computers have multiple cores. The second reason is the use of streams in the concurrent analysis. In terms of efficiency in operations like data handling, streams scale with the size of the data provided, unlike the use of for and while loops. Last but not least, streams utilize Lambda for Java 8, thus including a whole new toy box of powerful techniques where we can easily iterate through large sets of data as compared to for and while loops which the user has limited options to perform.